All right, hi everyone. We are looking at the next section in chapter 5, the special segments in triangles and special relationships in triangles. We've already looked at angle bisector and perpendicular bisector. So now we're going to look at our next kind of special segment, which is called a median. Now there's a couple of terms that we want to remember before we go into what a median is. And one of those, first off, is the midpoint. And what is that vocab term? So specifically, a midpoint is the point on a segment that cuts the segment into two equal parts. When we first visited midpoint at the beginning of the year, we talked about how it creates those two equal parts, and we called them essentially part 1 and part 2. And because it makes two equal parts, those two parts are congruent. They are equal in length. So if we were to come over for our little picture here, oh, sorry, my dot got a little off down there. Let's just fix that. All right, we have our, excuse me, we have our 2 points here. Let's say segment AB. And I need to make a midpoint. So again, I'm just going to estimate where I think the middle is. I'm going to call this point M. And again, that is my midpoint. So what that means for the two pieces that I've now created, they have to be congruent. So that's where the dashes are coming from. And this is where we get our part 1 and part 2. And again, because we have those dashes there, 1 dash on each piece, those two parts are equal. And that's where we get part 1 equaling to part 2. So we're going to be revisiting the idea of midpoint with a median. So when we talk about specifically a median of a triangle is a segment that connects a vertex, so one of the vertices of the triangles or one of the corners, to the midpoint of the opposite side. So these segments have to start at a corner and go all the way across the triangle to the middle of a side. So if I was to create a median here, and I'm just going to do 1 in for this triangle. If that point that I've just colored there is supposed to be the middle, the midpoint, then either side of that needs to be congruent. So 1 dash and 1 dash. And again, connect it, starts from the vertex all the way over to that point. That is my median. So let's kind of let's just visit that median, the idea of median for a second, and let's see what happens when we bring in some examples. So example 1, if segment GT is a median of triangle EFG. So before I go any farther, if GT is my median, then either side of point T there, F to T and E to T, they are equal automatically because of that midpoint. Those two parts are the same. So find FE. So here's what we're trying to find. Find FE if T to E is equal to 18. So they are telling me that the right part over here, T to E, is 18. Well, 1 dash with 1 dash, those have to match up. So because they're equal, I can copy it over. So F to T is also 18. Now, the question itself said find FE. So that is all the way across the bottom side of that triangle. So F to E is going to be the same as FT plus whatever's going on at TE. So in this case, 18 plus 18. So F to E would be 36 units, but have a length of 36. Now, let's bring in some algebra and see what happens. So example 2, find x if g to e is 3x plus 5. So g to e, that's the entire way across. So that we remember, I'm going to call this the whole length. And IE is an x plus 6. So it's just a part. But again, like we did before with the 18s, if I know what's going on at one of these parts, I can copy it over to the other part, x plus 6. And now I can get my x. Because remember, we talked about segment addition. Part 1 plus part 2 is the whole entire way across. But now because we're dealing with a midpoint where I is at, the two parts are equal. So part 1 plus part 2 give us the whole entire length. So part 1, x plus 6. Part 2, another x plus 6, again, because they're congruent. And the whole thing, 3x plus 5. Okay, and let's solve this. So first things first, combine your like terms. So we've got an x and an x. That gives us 2 x's. And then I've got a plus 6 and a plus 6. So plus 12 is equal to 3x plus 5. And now we've got our simplified equation here. Let's solve this out, because again, all we need to know is what is x. All right, so you've got variables on both sides of this equation. This is where I say cancel out the smaller variable first. So 2x, 3x, 2x is smaller. Cancel it first. So minus 2x to both sides. So 12 is equal to 3x, take away 2 of them. That is just an x, and we still have plus 5. Now we can minus the 5 to both sides. 12 minus 5 is 7. And so my missing x is 7. If it had said something different, find a specific length, then we would need to plug this 7 back in. But all it says is find x. So we did. So we're done. Let's try looking at our medians now when we have more than one happening in a triangle. Now, just like with perpendicular bisectors, we had a point of concurrency called your circumcenter. With angle bisectors, we had a point of concurrency that was the incenter. Well, medians has a point of concurrency as well, and this one is called the centroid. All right, the centroid of a triangle is the point of concurrency of medians. Now, we have some formulas that help with the relationship of medians and their centroids. So we look at this as, what do I need? Well, let's get them in here first. Let's get our 3 medians in here, and then we'll talk about what the centroid creates. So first off, let's say I need the the middle of one side. So if that dot that I just created is the middle, the midpoint, the vertex all the way across from it has to connect there. So there's my first one. Then let's say I have the vertex at the top connecting to the middle opposite it across from it. So again, if that new dot is the middle of that side, either side of that is congruent. And then we get our last one. Oops, got a little off there. All right, and again, the point where they cross, that is our centroid. Now, what this centroid point does is it creates a special pattern with each of those median segments. So one way to help with the formulas for these is to kind of label our different parts. Now, let's take a look at that last line I just drew. That median dot cut that segment into parts, but they're not the same length. The piece of the segment that connects to this side is shorter. And the other side of that segment is the longer. So the median are being cut into a short part and a long part. And that's the same for all three of those segments by that centroid. So I'm going to label the same things in the other segments. So I have a short part and a longer part. Same thing for the other segment, my last one. I have a short part and a longer part. And we're going to use those different pieces to create those formulas. Now notice each of the short pieces are coming off of a side. Each of the longer parts are connecting to the vertices. So that's very important. So let's see how we can use this to get our different versions here, our different pieces of this triangle. So let's say if we need the first one, let's say if I need one of the shorter pieces, well, there's two formulas I can use to get that. One of those is the shorter pieces are half the length of their longer parts. The shorter piece is also 1/3 of the whole entire segment. Okay, now we can use these similar formulas to get the longer part. So if I need a long part, it is 2 times whatever's going on at the short. So if I know the short, multiply it by 2, and I can get the longer piece. And if I need need the long piece and I have the whole, then it's 2/3 of the whole way across. And if all I need is the whole entire way, then I can add up my short part and long part, and then I know how far my entire segment is. So let's practice using those formulas. For example 3. Find RK. All right. So RK is the whole entire way across. Then it tells me D to K has a length of 6. So that right there is the shorter piece of that segment. DK is the short. All right, so if I need the whole, then I need to figure out the short piece plus the long piece. And the long is what I don't know yet. I need to figure out what is going on from RD, the long piece. Well, so if I need the long, then it is 2 times the shorter piece. So to get this missing side, I can take my 6, multiply it by 2, which means it's 12. So RK is equal to 12 plus 6, which is 18. Okay, so again, I needed to get the short piece in order to add the two up. And again, the longer piece is 2 times whatever's going on at the short part. Let's see what happens when we bring in some algebra. Okay, example 5. Given MQ is a median. So that means M to Q is a median and either side of Q is equal. So if I was to label these part 1, part 2, if I need them. Find XQ. All right, so XQ is a short part. So it doesn't look like I'm going to need the part 1 and part 2s. So find XQ. If M to Q is 3x minus 3, so what is M to Q? M to Q is the whole entire way. And X to Q, 2x minus 6. Okay, well, X to Q is the short. So let's go in and take a look and review those formulas for a second. So we're trying to figure out just X. So we need a formula that uses both the whole and the short. All right, and there it is. Short is 1/3 times the whole length. So that's the formula I need to use. So let's plug everything in. So 2x minus 6 is equal to 1/3 times the whole thing, which is 3x minus 3. And now we have our equation. All right, so first things first, we need to take care of the 1/3 in front of the parentheses. So we're going to have to distribute. So 2x minus 6 equals 1/3 times 3. That's just a 1x. 1/3 times negative 3 is just a minus 1. Now we can keep going with our solve. So I'm going to subtract my 1x from both sides. 2x, take away one of them, leaves us with an x. We still have minus 6 and equals negative 1. Okay, now we can add the 6 back. And my x is equal to 5. So there's the first thing we needed. Now it says find the length of X to Q. So I need to plug this back in. So X to Q was 2x minus 6. Well, now we know X is 5. So I'm going to plug it back in. So 2 times 5 minus 6. So 2 times 5 is 10. 10 minus 6 means XQ is 4. And there is my final answer. We found the length of XQ. Okay, guys, well, I hope you enjoyed learning a little bit about dealing with your medians and centroids in your triangles. Just remember, when trying to decide on which formula you need, follow the idea. If I need the short and I have the long, I'd use the top one. Short and the whole, just find the formula that gives you and uses the two pieces of information that you have in your problem. And then that'll help to find out your missing piece there. So guys, please don't hesitate to reach out to me if you have any questions at all. I hope you have a great day, guys. Bye.